This video, we will be looking at questions from stamp number 3. That is questions. Those are questions 15 through 22 and 29 through 31. Number 15 says, graph each exponential function. Identify the y-intercept, the asymptote, state the domain and range, and whether the function is increasing or decreasing. All right, we have 3 problems to do, A, B, and C, and let's get started. All right, since on the regular Algebra 2 exam, you can use your calculator. Let's go right to the calculator. All right, for A, we want to go 4 caret negative x. All right, if we put that in, we want to get a table. All right, now we should have some, we should be getting closer and closer to a particular value, and we can see as we go to the right, we are getting, as we go to the right, our values are getting closer and closer to 0. From our equation, there's k value is 0, so since the k value is 0, our asymptote is y is equal to 0. All right, our y-intercept is the value when we plug x, make x equal to 0. All right, if we plug 0 in, we get 4 to the 0 power, which is 1. So our y-intercept is at 0, 1. All right, let's get our table. Let's get some points from our table that are going to work. We've got -2, 16, might be too much, but good place to start. -1, 4. 0, 1, 1, and it says 0.25 or 1/4. All right, if you want to, and that's what's going to fit on our graph when we graph this. All right, so let's graph it. We're going to go right below here. All right. All right, our graph for this problem. All right, our graph for this problem, we have 0, 1. Here's blue. 0, 1. 1 1/4, and if we go -1, 4, and the other value is up here somewhere, say 16. All right, but we can see that our graph, and we should already know, they asked us is if it's increasing or decreasing. It's obviously decreasing. All right, its range, well, we have an asymptote here. All right, our asymptote is y is equal to 0. All right, and our range, since we just talked about ranges, everything above y is equal to 0. So we say y is greater than 0. Our domain is our set of all x values. And this graph, even though it goes up, shoots up, this graph will keep going up and out to the left. And it'll keep decreasing over the whole graph. It is going to keep on going. So we hit what? All real numbers. All right, and that is it for the first one. A down. All right, B. Again, we want to get some table of values. All right, so we got clear 4 to the x, and then if you, depending on what calculator you have, you gotta make sure you get out of that exponent. All right, +3. All right, table. Let's get some values. All right, in this case, we have -1 and 3.25, 0.4, 1.7, 2.19. All right, I'm gonna put a negative 2, 3.0625. Now, it's a growth equation because that base value for the exponent is greater than 1. All right. In this case, we could have written this one. I'm sorry to go back to it, but it could have been 1/4 to the x. Same graph. All right. And you see, if it's between 0 and 1, it would have been a decay, and we have a decreased graph. So for this one, let's see what we have. I'm going to erase this graph. All right. That whole graph there. Plugging points, we 1, 2, 3, 4, 5, 6, 7. All right. Oops, just messed that up. 1, 7. All right. 219 is way too high for our graph. All right. 0.4. 1, 2, 3, 4. All right. -1, 3.25. All right. Next point is 3 something. Every point will be 3 something. All right. Because we have a asymptote value of y is equal to. Asymptote value is y is equal to 3. All right. Your y-intercept, if I plug 0 in here, I get 1 plus 3 is 4, so it's going to be at 0, 4. All right, you have all real numbers because it goes all the way left and all the way right. All right, and so we'll see our asymptote is raised. All right, we had a lot of rules going on when we did this section. All right, run it up. All right, arrows at the end. All right, we see our asymptote. Our asymptote should be labeled as y is equal to 3. All right, and let's see what else we have to finish. Let's see, the range is everything greater than this asymptote. It's above the asymptote. So we want to say that y is greater than 3. All right, and if we look at the graph from left to right, we see that the graph is increasing. All right, and then the last one on this page, on this problem, see. All right, 2/3 to the x. Now 2/3 is between 0 and 1, so right away I know that this is a decreasing graph. All right, there's no plus anything here. All right, so it's plus 0, which leads you to your asymptote, which is y is equal to 0. All right, if I plug in to find my y-intercept, I'm going to plug 0 in here. All right, anything to the 0 power is equal to, you guessed it, 1. All right, every time for all of these problems, your domain is all reals, or you can write double bar R. I like the double bar R. All right, and then your range. Well, since none of the values, the a values in front were negative, it's always going to, when that's the case, this is y is greater than whatever your asymptote value is. All right, and so that's going to be everything, even before we get the graph. But let's get the table of values. 2 divided by 3, close it, to the x, delete everything else. All right, so that's what it should look like. 2 divided by 3 to the x. All right, hit table. All right, what we get here is a, let's see, we're going to go -3, 3.375, -2, 1.25, negative 1, 1.5, 0, 1, 1 2/3, 2 is 4/9, and that should be enough for a table. All right, graphing that. All right, graphing our asymptote first gives us that. All right, y is equal to 0. Excuse me. 0, 1. 1 2/3. All right, so forth in the other direction. That's negative 1, 1.5, negative 2, 2.25. All right, if we continue along to the left, this thing increases to the left. All right, increases to the left. All right, as we go to the right, it gets closer and closer to 0. There's your graph. There's all your answers. All right, for problem number 17 through 22, we need some of this information from our formula sheet. All right, compound interest formula is given, and the continuous compound interest formula is given. We call it the shampoo formula. All right. All right. Now, we need to remember that the other formulas come from this compound interest formula. All right, if it doesn't mention, if it's an increase and it doesn't mention compounding, then we go with the general equation. All right, our general equation is A is equal to, because n becomes 1, A is equal to P times 1 plus R to the T. All right, that's that general increase formula. All right, if it's a decrease, if it's the decrease formula, all right, the plus becomes a minus. All right, and basically, I mean, those are all the equations we need. All right, the other thing is that when we do use that compound interest formula, we need to know our values of n. All right, and they won't be given to you. But if we're talking about something compounding weekly, we say n is equal to 52. If it's quarterly, which we usually come across, all right, n is equal to 4. If it's monthly, well, how many months are there in a year? All right, n is equal to 12. All right, if it just says annually, all right, and when it does say annually, that's where we're using this general form, all right, because n becomes 1. All right, so let's see if we can do some of these problems. It says number 17 says, in 1990, the population of a town was 5,000. The population increased at a rate of 2.5% per year. All right, so when we're doing these problems, we want to pull out that important information. All right, important information. 1900 is when it started. The population of the town was 5,000. All right, and the rate of increase is 2.5%. All right, so if we pull that information out for number 17. All right, we have P is equal to 5,000. All right, it does not, your R is equal to 2.5%, which we changed to 0.025. All right, it doesn't mention compounding. All right, so we're going to take it, n is equal to 1, and we're going to use that general form, the general increase. Not, of course, the general decrease. All right, writing our equation for this problem will yield A equal to 5,001 plus 0.025, all right, to the t, all right. All right, so that'll give us an equation that'll allow us to find the population at any given time, all right. So for A, they asked for the population in 1920, all right, and since they're asking for that, the time that has elapsed since 1900 is 20 years. All right, and so we go 5,000 times 1 plus 0.025, or you can bring that together, to the 20th. All right, and if we do that, do the math in our calculator, all right, for that problem, let's see, what do we get if we punch it in? All right, we get 8,193. All right, don't need any decimals. All right, 8,193. All right. For part B, they want to know the population 1950 to the nearest whole number. All right, so in that case, we have 2 is equal to 50 years. All right, we'll have 5,000 times 1.025 to the 50th. All right, and in that case, our answer is 17,186. Number 18. A luxury car originally cost $75,000. It depreciates at a rate of 25% per year. So, 2 things are in the problem. You have $75,000, all right, which is that original amount. We're going to call it P. All right, it depreciates. All right, if something depreciates, it loses value. So we're going to go with the decrease formula. All right, so A is equal to P times 1 minus R to the T. All right, so you got $75,000. All right, 1 minus, all right, it's R, the rate is 25%. All right, remember we have to change this to a decimal, moving our decimal place 2 times, that's 0.25. All right, 0.25 T. All right, now that means if it decreases by 25%, that means there's 75% left over. All right, if you do this 1 minus a quarter here, all right, you got 75000.75 to the T. All right, now that gives us a model. All right, it says what will the car, A says, what will the car be worth to the nearest dollar after 5 years? So we're talking about T equaling 5, 75000 times 0.75 to the 5th power. All right, and if we do that correctly, let's see, 75000 times 0.75 caret 5. The car is worth $17,797, up $98 because the 80 said 85 cents. All right, so that would be the answer to the nearest dollar. All right, and B, all right, it says what will the car be worth after T years? All right, and in that case, they just want the model. All right, so the car will be worth 75,000 times 0.75 to the T. All right, so they're asking for a model in that question. Number 19, a town has a population of 250,000. Due to a loss of jobs in the area, the population of the town decreases at a rate of 5% per year. All right, so it's a decrease. All right, that lets us know that we're going to go A is equal to P times 1 minus R to the T. All right, the initial value is 250,000 at a rate, so that's P, at a rate of 0.05. All right, and let's get that in. Let's answer the question. A, write an exponential model that describes the situation. All right, so A is equal to 250,000 times 1 minus 0.05. So once again, to the t. All right, that would be 1. If you want to simplify this, you can. All right, and if I simplify it, it becomes, so as you think of it, if there's a 5% decrease, then that means that there's going to be how much remaining. All right, and you could just think of it as a dollar. If I take 5 cents out of a dollar, how much more? How much will I have left? All right, and I'll have 95 cents left. So it's the same thing for this. If there's a 5% decrease every year, I will have 95% remaining. All right, and so that would be the best equation for that. All right, question B. All right, what is the expected population of the town in 10 years? All right, so A. All right, and some people make this a P population, but we were already using P. We want to, variables don't matter too much in this case. 250,000 times 0.95, and it says they want the population. The time is what? 10 years. All right, so after doing calculations in our calculator, all right, we can say in about 10 years there's going to be 149,684 people in 10 years. Number 20, an account pays 4% interest compounded monthly. R, 4%. All right, compounded monthly. All right, so we're going to go to that compound interest formula. Compound interest formula at the top. All right, so we're compounded monthly. You deposit $6,000. All right, $6,000 into an account. If you do not deposit or withdraw money from the account, how much money will be in the account after 5 years? So just pulling the information. There's your T. All right, so compound monthly lets us know that, well, monthly, how many months are there in a year? And there are 12 months. So N is going to equal 12. All right, we have our P, we have our T. We want to change this 4% into 0.04. Sorry if I'm blocking. All right, and we have everything we need. A is equal to P times 1 plus R over N to the NT. All right, so let's answer this question. All right, we have 6,000 times 1 plus 0.04 over 12 to the parentheses 12 times 5. All right, you want to fix this up in the calculator, you can, or you can enter it as just like this: 6,000 parentheses 1 plus 0.04 divided by 12 close caret open 12 times 5, or you can just change that 12 times 5 to 60. All right, that's going to give you your answer. All right, and in this case, A, for number 20, A is equal to $7,325. Looking at my decimals, 98 cents. Number 21, you deposit $1,000 into an account to save money for a car. The bank pays 7.4%. There's your R. All right. If you neither deposit nor withdraw any money from the account, how much money to the nearest cent will be in the account after 6 years? T is equal to 6 years. All right. If the interest is compounded continuously. All right. Very clear what problem to do. We're doing that shampoo formula, that shampoo equation. All right. PERT. That's why we say that, because actually PERT is a shampoo. All right, so let's go. A is equal to P times E to the RT. Now remember, E is a constant. All right, it's a constant. It's that second natural log key in your calculator. All right, if we look at this calculator, it is that button right there. That's that natural log, that LN key. All right, so we want to make sure we use that thing. All right, A is equal to 1,000 E times 0.074 times 6. All right, if I plug all that into the calculator, all right, for number 21, I get $1,558.93 after 6 years. Now remember, when you're doing these problems in the stamp sheet, you got to show all these steps. All right, writing this final answer is not going to get you any credit. Number 22, in a bacterial culture, the number B of bacteria present is modeled by B is equal to 15,000 E to the 0.27 T. All right, looks like the PERT, looks like the compound continuous equation, which T represents the time in hours. All right, so T is hours. All right, since noon, since 12 noon. All right. All right, the questions ask us, how many bacteria to the nearest whole number will be present at 5 p.m.? So from noon to 5 p.m. is how many hours, guys? 5 hours. All right, so to answer that question, A, we want to plug 5 in for T. All right, so we have 15000 E to the 0.27 times 5. All right, and if we do that correctly, punch that in a calculator correctly, going 15,000, hitting the second natural log, and keeping 0.27 times 5 in parentheses, all right, we should end up with 57,861 bacteria present. All right, there's A. And then B. All right, let's see, B. For our B problem, it says, how long, correct to 3 decimal places, will it take for there to be over 120,000 bacteria? All right, so they want to know how, when or how long it will take. So we're looking for time in this question. We're looking for time it will take for there to be this value. We want to take the right side of the equation. All right, E, this is what they give us, 0.27 T. All right, and we want to set it equal to, all right, that 120,000. Now, I'm going to solve this algebraically. If you would like to use a calculator, you have to be proficient at getting a proper window that shows a point of intersection. All right, I'm not going to do that. We're going to solve this the same way we solved this year. All right, we're trying to solve for T, so we're going to divide both sides by 15,000. All right. 120,000 divided by. All right, that gives us 8 on the left side. 8 is equal to E 0.27 T. Now, I want to get to this T. I want to cancel the E. Remember, the inverse of E is, you guessed it, natural log. So we want to natural log both sides. All right, that will cancel. That E And the natural log, pen's not working. All right, that leaves us with the natural log of 8. I hope we're still on the screen. Yep, we're still on the screen. Natural log of 8 is equal to 0.27 t. And then I'm still trying to get t by itself. So what we're going to do, divide both sides by, you guessed it, 0.27. All right, and that lets us know that t, I'm just going to switch sides with it because that cancels. T is equal to the natural log of 8 all over 0.27. And when we put this in the calculator, we want to go ln. It's going to give us a parentheses, 8, close it, divided by 0.27 to get the proper answer. Oops, sorry, ran off the screen. All right, so once again, natural log of 8 over 0.27 is equal to, this is what we want to type in the calculator. All right, that tells us that t is equal to, what'd you get, guys? 7.702 hours. All right.